Welcome, everyone. We have a very exciting topic, and we're going to talk about taint analysis. And I'm your host for today's live stream. And with me, I have some of my colleagues who know way more about this topic than I do, so I very much appreciate them. Would you guys mind introducing yourself?
Hi, I'm Dima. I work in JetBrains in Qodana team. I'm a team lead who is responsible for creating Taint Analyzer for Java and Kotlin that we are going to discuss today.
Hello, I'm sorry to interrupt. Hello, I'm Alexander. I'm working in JetBrains since 2010. I'm in Lion team and partly in Qodana team. I'm the developer behind the DFA engine that's used in our taint analysis that we are talking about today.
Hi everyone.
Awesome.
My name is Gregory. I'm application security specialist here at JetBrains and partly software developer. So I'm interested in things like taint analysis and SAST analysis.
That sounds awesome. I'm very excited about this. But before we get started, let's talk about some of the general housekeeping things, just to get everyone on the same page. So, as always, if you happen to have any question, please put that in the chat. This way the session gets more interactive. We can make sure that all your questions get answers. Just put it in there. I might not get to it right away, but I'll take care of them and put them on stream the minute when it fits in. Additionally, because this comes up every single time, yes, this will be recorded. So if you happen to have a meeting halfway in, you can watch the rest of the show afterwards. This is YouTube. This is the internet. The internet does not forget. So this will be here afterwards. Same link. And that is literally all the housekeeping we have to do. So with having that said, we can jump right in the topic. Are you guys excited?
Very excited.
I love that enthusiasm. So I think before we go super into the weeds of taint analysis, the thing that I'm most familiar with is like the most obvious ones, like SQL injection, those kind of things. What are some emerging threats that can be detected by taint analysis that people might not be familiar with?
I think it's a question to me. So yeah, it can detect a wide range of security vulnerabilities. And taint analysis engine is just a tool that can track user input or other dangerous or malicious input from the source to the dangerous place in your code, and we call it sink. And if you can track this from one place to another, so the whole your method calls, function calls, etc., then it will be it raises the issue, right? And only the type of vulnerability depends on the combination of source and sinks. And you can configure infinite numbers of sources and sinks and detect even your own issues that could be something more interesting like authentication bypasses or detection your own type of vulnerabilities inside your code.
To some extent, you touched on this, but why? Let me put it super bland. Why should people care about it?
Oh, wow. Why should people care about security or application security? There are many reasons.
Let's focus on taint analysis, because security in general is a much broader topic, right?
Okay, yeah, right. There are many SaaS tools that can detect a lot of vulnerabilities. Many of them will be false positive because they can detect unsafe pattern in your code and will raise an issue, right? And you have thousands issues that you should validate as a security specialist. But if you can prove that there is a flow from an unsafe source to unsafe sink, then you could guarantee that's a true positive issue and that there's something that you can reproduce, exploit, and send to the software developer team to fix, because it will be really like most important issue. It's just easier to validate them because they have a proved flow from the source to the sink.
Makes sense. So, because we didn't have features for this from the get-go, why or how did we come up with the idea of like, let's implement something for taint analysis? Let's make this easier for developers. Like, what is the process behind that? How does it look like?
Well, I'm an answer. I've been working with Qodana team for over a year and a half now. Before that, I was developing software analysis tools for C++ in C-Line. At some point, I made static analysis language agnostic and interprocedural and added support for some complex analysis, such as buffer overflow detection, memory leak analysis, lifetime analysis, etc. And eventually, I realized that existing engine could be reused for some other purposes, not only for C++, for example, for security-related tasks. That's when the idea of applying it to taint analysis came up. We collaborated with Qodana team and reused our engine that was used in C-Line for taint analysis tasks. And during the development, we faced several challenges. The security analysis must have high accuracy, few false positive, high performance, etc. And to meet these goals, we had to do the deep rework of our engine, and we faced some really complex and interesting tasks.
Okay, you cannot just like leave me hanging there. Oh, we faced some interesting tasks. Like,
Yeah,
can you elaborate on that? Like,
I just wanted to say that the work was really interesting for us, and with all the enthusiasms we came to this task. Yes, and this task was
gotcha.
really
Just like from a developer challenge perspective, or
it was a really challenging
mean?
task. Yeah, it was a really challenging task because earlier in C++ in C-Line, our analysis didn't reconstruct the traces from source to sink. It only showed the actual point in the program where is the warning, where is some malicious code, etc. In taint analysis, we couldn't do this. We had to show the trace for the user, and reconstruction of this trace was a really complex task because our engine was not supposed to reconstruct the trace. We had to did it backward, to do backward computation. It was time consuming. We had to do some optimizations for it, etc.
Interesting. Okay.
I may also shed some light on my opinion on this subject, if you allow me this. So basically,
sure.
When I came to JetBrains, and I was I was already familiar with IntelliJ Ultimate. However, like when you start dealing with all these inspections, I would say those inspections that are not DFA based are something like boring. Okay, for example, my name doesn't match the formatting rules, or I just have an extra indentation or something like this. That just, it's boring for me. Okay, I can obey some formats, but however, those are simple linters. But when you start talking to the customers and start talking to the big guys from big firms, they're asking for several topics that are very valuable for them. And one of them is security. And unfortunately, we've realized that actually there is nothing, the offering that we currently could have offered to those people was very limited in terms of security. Of course, there were like some inspections, part of them were disabled, that were offering some kind of security checks. But if in reality we want to make sure that your software is prone to like vulnerabilities that could be detected by taint analysis, the opportunities were really limited there. And my take on this question was that I wanted to for us to have a tool that will be accessible for everybody who is using IntelliJ IDEA Ultimate. And moreover, I wanted to make it different so that it will be available with the speed of your typing. So if you type your code, it will instantly highlight the problems in your code. It will instantly find those vulnerabilities. And there are not that many tools on the market that can do this type of thing. And for me, it was more question of like, if we can make such a tool that will be accessible to everybody who are already our customers, who are already using IntelliJ Ultimate, who already own this kind of license, and then they can make use of it. They can really benefit from it just by checking the results from time to time and improving their code if they find that, okay, we found a true positive. And I'm pretty happy with the outcome.
Talking about the outcome, I think one thing that I'm interested in, and you to some extent touched on that, but what is something where our approach, or what are the strengths of our approach, basically, compared to other solutions?
I have to say that our analysis is quite precise. It models many language features and takes into account function calls, fields, condition, etc., and all the ways that data can propagate through a program. It helps to reduce the number of false positives, makes analysis more useful and convenient. You don't have the tons of garbage in your output, and you don't have to filter which of these are true, are really true, or which are false, because our analysis produces quite a few false positives, yes. And also it performs very efficiently on the large code bases. For example, our internal project that we use for analyzing is a project Team City, which has over 7 million lines of codes, and currently we can run the analysis within 45 minutes, the whole analysis of this large project. So it's very precise. It has low false positive rates, and it's still very efficient. That's our strengths.
So
comparing to.
You also mentioned that it covers a lot of language features, which I'm somewhat surprised by, because Taint Analysis often involves like language-specific features. How does that work if I decide now, oh, my new project should be written in COBOL because that's the cool stuff right now? Like, how does the Taint Analysis help me with that if I write something in a language that might not be like in the Gardener super interesting category right now?
Do you mean if you write something not in Java or in Kotlin? No, currently
Yes.
our analysis supports only Java and Kotlin, but our DFA framework that is beneath, it's actual language independent, and it's quite easy to implement the front end for a new language if we choose to support this. So our framework supports the basic functionality, and the translator that is a top layer. We have several translators from several languages to this DFA framework.
Gotcha.
I would say it somehow aligns with the whole JetBrains offering. So, you know, like IntelliJ IDEA already offers you, for example, structural search. That's a kind of a meta language when you can specify a query and find something that is security related, or that is like some bad patterns you want to find in your code and fix them. There is also, you can also write an inspection, like write an IntelliJ plugin and then use it within the IDE or in the CI/CD pipeline with the Qodana. Or you can use also Flex Inspect. That is something that we've released recently. Is there where you can define the inspection within the code of your project in a special folder within the Kotlin language, and then it will be immediately injected in all of your inspections that are currently running. And in order to extend this framework, we also wanted to extend it with kind of data flow analysis. And this is our take on this, so that we align that the user can define his or her own configuration, so that it will be possible to track particular things within the code base. So I think that we are still pretty aligned with our offering, and yeah, that's it.
Okay, cool. So you mentioned before that the Taint Analysis we have written runs directly in the IDE, but often maybe someone also happens to have not to use our IDE for whatever reason. Are there offerings outside of our products, like CI/CD pipelines, those kind of things?
Yes. So actually, if people are not using our IDEs, they can still maybe benefit from our analysis. There are like there is a product, there is a team we're working on. It's Qodana team, which is responsible for releasing linters, which are based on our products. So actually for Java, there is a linter called Qodana JVM. And when a user has matching subscription, it's a paid subscription, I think Ultimate Plus, or correct me if I'm wrong. I think that's the richest one, I would say. If he has this kind of subscription, he can run the analysis within the pipeline, and this inspection is enabled in the default Qodana starter and in Qodana recommended profiles. So the user can benefit from the inspection and can see the findings in Qodana Cloud, or by using integrations such as like integration within the VS Code with our plugin, Qodana for VS Code, can see the issues in VS Code-based IDEs and can fix them.
Cool. We do have a question in the chat that I would like to pull up. Let me apply some magic here. OK, so you must be very excited about the new K2 compiler and the analysis API. Has the new API helped improve the data flow analysis in Qodana?
That's a very tricky question. Actually, I'm missing one of the developers who would be happy to answer this question. I would say we're very happy that the team was able to address a lot of problems that we had with K1, because actually we are, so the team where Alexander is working is responsible for the engine, and the Qodana is primarily working on the front end. So we really rely on the API capabilities to resolve stuff, and like if this thing doesn't work or doesn't produce the expected results, the output quality of the analysis will be much worse. So I would say that we've have almost all of our problems solved within a K2 in comparing with K1, where we still have some tickets opened, and we decided not to pursue with some fixes. So with the K2, it is really much better, at least for us as for engine developers.
Awesome, thank you. So, Grigori, you as a security expert, as we discussed earlier.
Let's call that way.
So how does taint analysis come into your workflow? Like, how does it help you in your daily workflow? How do you utilize it, basically?
Well, it's long story, but I try to keep it short. Yeah. So when I joined JetBrains, it was like kind of a task for me, like to evaluate internal tools that we have, to apply them and find security vulnerabilities. And our goal was to find the real exploitable vulnerabilities that we can and we should fix as fast as we can. And we started with the structured search in the place that Dimo already mentioned. It's our pattern matching approach. It can find problem in source code. It's powerful, but it cannot track data flow. It cannot prove that there is a flow from user input to unsafe code in your application, right? And we started to switch to another thing that we have kind of simple taint analysis inside of some of our inspections that are available in our IDE. It was a big step forward, but wasn't enough. Then we started to share these ideas and results with Qodana team, and gladly they decided to help us with the proper taint analysis. And now this taint analysis is using on a daily basis. Now some of scans for inside CI/CD we have, and finding exploitable issues pretty often, and it's a good solution for us.
Cool. I also happen to know that you prepared a fancy demo for how this taint analysis works.
Yeah.
Would you mind enlighten me?
Yeah, let's try. So first of all, let's open our favorite IDE and IntelliJ IDEA, right? Let's navigate to problems here, and we have this new tab, security analysis. Let's just run it with the default configuration as it is. Let's wait a bit. It won't take long.
So is it just for my understanding, I assume you don't have like a COBOL project running, but more like a Java Kotlin kind of server something?
Yes. Yeah, I missed this part.
Okay.
Yes, we are going to check WebGold application. It's famous OWASP project to educate software developers and application specialists in finding and fixing security issues and exploiting them as well. And we'll try to do it today. So yeah, we have
Sounds good.
results. It was pretty fast. It's just inside your favorite IDE. And let's start with the very first issue that we have here. So what do we have? It's deported last uncontrolled user input is passed to SQL injection thing. Let's check the flow. And we have sync here, and we have all the steps back to the user input. As Alexander mentioned, it was built for our use case. We have all the steps. We can navigate through them, and we can see that here in SQL statement, we are providing user input as a password login as is, and it's a dangerous pattern. Let's try to check it inside the application. So here we have a WebGold application, and it's deliberately insecure application, as I mentioned. And we have this challenge. We should login as Larry. Let's try. We know, oh, sorry. Have a username and we have password, but we don't know it. Let's try. It's not the correct password. Yeah, it was expected. Let's find the request that we sent to our server and send it to repeater in our favorite interception proxy. And I mean favorite for application security specialist or expert. Yeah, password is not correct. Please try again. Okay, let's check that we have SQL injection as it was mentioned by Qodana. Taint analysis. We tried to break the context of SQL exceptions, just made a mistake inside the statement. And we see this SQL syntax error exception. So we are on the right track. Let's go back to the code. So we have, or even we can see it here, like we have select password challenge where user ID is Larry and password equals to 1. But password is not equal to 1, we don't know it. But we can make this statement equals like statement made true by adding something like 1 equal to 1, because it's always true and we have or, so it will be passed through these checks. Yeah, congratulations, you solved the challenge. Now it's for application specialist, we validate the issue, it's valid and exploitable. It's time to report it to software developers, to the product team. And it's not convenient to show the example from the IDE, right? And here we can try this CI/CD approach that Dima mentioned. Here we have another tab. It's called server-side analysis. It's Qodana plugin inside our IDE, but we can try to run it locally without CI/CD or linters. Just using the default profiles called Qodana starter. And here we have our JetBrains Qodana JVM, as mentioned by Dima. Let's run it. It won't take long, just analyzing the project just inside your IntelliJ IDEA. Yeah, we have results, and we have results on Taint Analysis. It's possible to open it inside the browser, and usually it's uploaded to Qodana Cloud. It's another project that's combined with Qodana linters pretty well. And here we can use category security and find SQL injection. It was inside the class assignment 5. And here we have the same taint flow in one place from the user input, our source number 1, to the final top where it will be executed. Isn't it cool? So then
So
we
cool.
can, yeah, then we can just copy link. We can copy link and just open issue tracker, report all the steps to our software developers, and even share the link. It will be possible to open it. They'll navigate to the issue inside the Qodana Cloud report, or it could be open locally. Yeah, let's move forward. The problem is that sometimes we don't have some results from our engine, but it's not like a mistake. It's due to the possible reasons, like in this case. We have a pretty completely valid example from this reflected XSS attack, and we have user input here and here in some of this field, I don't remember exactly, and it's propagated to the flow to the output, right? But output is a custom code, and it's not covered by our engine by default, because it doesn't make sense to cover all possible combinations, especially if it exists only in one particular project. Or it could be closed from the for it's not open source, so you don't know your things, and it should be configured separately. Let's create a new directory. It should be called inspections. And inside this, we'll create a custom inspection, and this will be new Taint configuration. We will call it like custom DFA. And inside this, it's possible to add some new things. And this thing is a attack result builder from this WebGoat application. We are going to track first parameter, and it will be called Taint rule, because it's XSS type of issue. Let's take a look. So it's one line just to configure one custom thing. Let's recompile it and open the results. Well, we have results. 3 valid reflected cross-site scripting issues. And you can deconstruct the whole DFA again just inside your IDE. You can check back to the user input. It was field number 1. It was propagated through Steam Builder, and we continue to track it, and it will reach the unsafe output. Let's validate it. Here in our injection section, we have cross-site scripting as exercise number 7. Let's try to click the button. Okay, here we have the line like we have charged credit card. It's the same as we have here on the step number 2. So it means that here we have user input that will reach unsafe code without validation. Let's provide simple XSS payload and reproduce issue. Congratulations. Alerts are not very impressive, are they? I think it's very impressive. So it's working. Yeah, and it's also possible to restart the analysis. Like we can try it again to analyze the project, and we'll find this issue using custom configuration with your own things inside the Qodana Cloud results. Now it will be just local results. But if you have subscription and you have projects inside Qodana Cloud, it will be possible to find it. Let's update results. Here, navigate to XSS, find this cross-site scripting lesson number 5, and we have this field number 1, charge the credit card, all the steps to the final result. And even this is not all. It's not all. We also found issues outside of the designed vulnerable application. WebGoat contains 2 applications. One is WebGoat, and second is called WebWolf. It's an application to help you solve the tasks. And in this application, it was it contains one undesigned vulnerability, past traversal, and it's possible to find it, like the whole steps from the source to the thing. And if you send a file, you can store it outside of the design directory, or you can remove any file outside of the design directory. And it's kind of dangerous application, kind of dangerous vulnerability. Let's try to validate it as well. Here we have WebWolf. Here's the functionality to upload files. Let's upload something. Oops. Let's choose a file. Upload. Find a file upload request in our interception proxy. So let's repeat it. We have upload success, file upload successful. But let's change a bit one to several level ups and then store it inside temporal directory. We'll call it something like act.txt, and text will be act. We'll send it. Upload is successful. And here we can check it in our temporal directory. It was called hacked.txt, and it's inside. So it's outside the design directory, so you bypassed. So, but there were any protection rules, we bypassed it, and it was again validated, and it's time to report it to the developers to fix it. Basically, that's all.
That's super interesting. Okay, there's another question in the chat that I'll pull up. Okay, so you have a DSL for Kotlin file or KTS files in Taint Analysis. Oh, that is not a question, that's just a statement. I appreciate that. The team did great work on that. All right. If you have any question or scenarios where you would like to use Taint Analysis, please keep them going. Otherwise, I'll keep going with my questions.
I can add one short comment to this DSL question. It's not just about things or sources. It's possible to provide more complicated logic, and I think Dima can evaluate it. So you have the whole range of configuration could be really flexible and adjusted to your project. So you can find your own type of vulnerabilities.
A little bit later, we'll also publish some materials on how people can extend the behavior of this engine. However, we believe that most of the people should stick to our configuration, and just by slightly extending to the special frameworks or libraries they do use. Basically, I do a lot of research with the help of ChatGPT. So you may find it also valuable for you to mine additional configuration items for your specific project with it and make use of them.
Cool. I think with the demo that you just showed, you convince at least most developers, right? The configuration is very easy, the approach is very easy, and it gives a lot of information, particularly for a domain that I, as a normal developer, are not super familiar with. But what is the benefit for like a company at the end of the day? Why should I'm CEO of super important company XY? Why should I care?
Well, in application security or any security, there is a kind of term about like a trend, and it's called shifting left. And the most left position in this software development cycle is your IDE, right? It's where developers are writing code. And if you can detect vulnerability just after the typing, in type of typing your code inside your editor, that's the most, like, I don't know, it's fastest way to provide you feedback and stop you from making mistakes and vulnerabilities that could cost companies money in many ways. Like the hackers, they will exploit it. It will be bad for reputation, and money loss and reputation loss. Or even it will be reported by good guys like researchers from the market. Usually a company paying bug bounty, and it costs a lot of money. Or after this, you should spend your developers' time, a quality assurance specialist time, to fix the issue and validate it, because you want to be sure that you fixed it, right? So in all the cases, the sooner you will find the issue, the cheaper it will be for the company. So yeah, makes sense for the companies as well.
Do you have like a real world example, something that you encountered, or some like known case that makes this a little bit more tangible? Even though the demo was great and everything, but I'm like, from my perspective, I'm like, oh yeah, I'm obviously thinking about SQL injection, right? That's so obvious. And when I'm typing, I'm not doing it. So having like this real world scenario could help me not do it again and not be stupid.
Well, there are many cases, because you can configure your own pairs of sources and things. Those was one very important and interesting case with our internal project, Team City. 1 year ago, it was reported 2 interesting vulnerabilities by Rapid7 team. And they really help. Glad that they found it and reported to us. We fix them, but the important part is like lesson learned. We should kind of find all these kind of vulnerabilities and be sure that they're all fixed. And Taint Analysis helped us with this kind of issues a lot. So without Taint Analysis, what you have? You have 7 million lines of code, and what you can do, just validate line by line. It's impossible.
Okay, now I'm super curious from your background. If you're not using Taint Analysis and you cannot read 7 million lines of code, like what are you going to do? Like just like manually trying to break things, or how do things look like?
It's always a kind of mix of approaches. We have many tools, some of them called as well as SaaS tools, not just Qodana, other tools on the market as well. We have many results from different kind of scanners for different projects. We're scanning code, we're scanning running application. So from external approaches, we have network security specialists. So we're taking a look at every and each application from different angles. For the new code, if it's important part of a system, colleagues from application security team or product security team, they're taking a look like manually or by their own eyes, they're reading all the lines. But if you have a big project and you have some legacy, you have some old code, it's not possible to reread the whole application after finding a new dangerous pattern. And you should just configure it somewhere in your static analysis tool and then evaluate the whole code base, find issues, and then again take a look manually and validate them, report to the software development team. So it's not like a one-time thing, right? So security is more like a process, never-ending process that should support software development lifecycle.
Yeah. So hopefully that rarely happens, but in case there's a security vulnerability that come up, like what is a good approach or pattern that you have seen, or one of you, that makes sense, or like to address those issues? Because usually there are timelines for things, and security issues are important, but how do I make sure as a company that they're getting addressed properly?
Well, I think it's a pretty interesting question with no generic solution. So it's like we have a lot of inspections that, for example, we have quick fixes for, and it's not that very easy to build a quick fix for a taint analysis problem, because some problems, when you work on a real code project, some problems could be fixed by just removing some attributes, or some problems could be fixed by injecting some middleware that will check for you. Some problems could be fixed by using another approach, for example, switching to a different ORM and just stop writing SQL queries per hand. And some problems could be fixed by manually checking for patterns, or using some well-known validators. But I would say if I have met such a problem, at first I would at least Google something with, okay, I have an XSS. I have, for example, XSS prevention or WASP. And then I can run into some cheat sheet that will help me to prevent this kind of vulnerability. And then I would also do extensive research, also with the help of ChatGPT or Gemini, or like you name it, your tool, like with any AI tool, or even with the help of our tools. And then if I have, for example, application security specialist, I would reach out to them. Probably they have such kind of experience. And like based on this, I will fix this vulnerability and will probably share my experience with my colleagues. And we'll also probably build some custom rules that will help us to identify those problematic pieces of code earlier than they hit the production.
It's like a long and 100% correct answer, but I have kind of funny answer if you let me in. I would like to share my screen. Yeah, and we have an issue here. It's called SQL injection, right? And you can find it in your code. Just in where it is. So we have our sync here. So you have a SQL injection here, and it's highlighted by our tool. But let's fix it. Just wait a bit. So yeah, now it's 100% correct code because we have precompiled the SQL statement without user input, and we provided parameters afterwards. So it's not possible to break the context, and issue is fixed and was highlighted by Qodana. And I think that AI, it's not just for vibe coding, it's also for vibe application security, right? So that was a short addition to the demo. I think we can move forward in this direction. Dima, what do you think?
Yeah, we also want to add this opportunity for the people to generate AI-tailored fixes because, as I've told you before, it's not that easy to build in some 100% accurate technique. And we are looking forward towards integrating more AI capabilities within our Taint Analyzer and also enriching existing AI offering that is being currently made by JetBrains with the products that we are working on. So with the Taint Analysis capabilities, so that people can make sure that we did our best in order to prevent like those issues from popping up in their code base.
Yeah, that totally makes sense. And I would like to broaden the scope of this question a little bit, if you let me. So you touched on the things like, okay, we would like to integrate AI or like basically like more elaboratively tell the story of AI and taint analysis. But what are other things coming to taint analysis in the future? If I already have the people here that work on that, I also want to know like, okay, what's coming? What's on the horizon?
Well, good question. First of all, we already talked about true positive. So building a taint analysis tool, we want to increase true positive rate and decrease false positive rate. So that's actually where we are heading towards to, and you will be able to experience major efforts within 2.5.2 release happening this summer. Since we've, thanks to the efforts of Alexander, we've made a huge progress on this, both in time and speed. But that's just one part of the story. The second part of the story is that we want to build more realistic benchmarks, because the application Grigory showed you is like something like handcrafted application that was made specifically for like researchers, for like developers, or like broader audience, but those are not real applications. And we already have some like sources where we can gather like real world application problems. And we want to, first of all, we want to benchmark on real world applications and to see whether we can spot the issue or not. And we want to increase our detection rate, because it's also is a proven fact that if we improve our inspection tool, we'll start find more interesting issues also in internal projects. And apart from benchmark, building better benchmarks that are based on real world issues, we also looking forward into extending our offering to other languages. We are not that fast on this. Yes, we have an engine that is easy to support new language for, but we are trying to find a balance between enriching our offering for existing languages and adding new languages on top of it. But you may expect new languages being supported like within next months, years, or so.
Undefined time range XY. Love it.
Not that. So actually, supporting Java took us almost, I would say, a year of a development time, Java and Kotlin. and we are still improving our Kotlin translation, so we are still not there. And so it's not that very easy, but we are trying to find a good balance between extending our offering within a language and supporting new languages.
Makes sense. There was another interesting question in the chat, and thanks, Jordan, for keeping those questions coming. I really appreciate you. Is the Qodana source code open source? I would like some of the other JetBrains tools. I would love to see how the Taint Analysis DSL is defined and also used in the plugin. And I think this is a great question because I don't know the answer either.
Well, I would say the source code of the language frontend and the source code of the engine is actually not an open source code. However, we are still looking into opportunities of making the inspection to be better documented. So we may make it public the way how we define those DSLs. And of course, like IntelliSense is working. When you create this KTS file, you'll be able to see like auto-completion that will work for you, and you may explore the DSL that way. And we are also working on help pages so that you can explore how you can use it. However, unfortunately, due to the fact that it's our intellectual property, and like we have decided to keep this plugin proprietary, and yeah, it's not available in community edition of IntelliJ, so we have no plans of making it open source. Sorry.
Thank you. There is another question by Finn. How does Taint Analysis and Qodana integrate with CI/CD pipelines, and what best practices would you recommend for automation? We touched on this earlier a little bit, but let's maybe recap. Who wants to take this question other than me?
So I think yeah, you can also answer this question by yourself.
Nah.
Actually, the easiest way to explore this will be like just Googling Qodana CI/CD, and there you will find that we already support a lot of integrations. For example, with GitHub, with GitLab, with Bitbucket. So on our help pages, we provide the changes that you need to make in the configuration in order to make our linters running. Our linters will be executed on your agents. So actually, we are not executing any kind of analysis on our side. We just host the results.
Okay.
If you are not using on-prem solution. And so if, for example, if you're using GitLab, GitHub, then you can just Google Qodana GitHub, and then you will see the workflow, the simple workflow file you can use, and everything that you need to do is just to create an account in Qodana Cloud, accept the trial, and just get the token. Then you will store the token within the security configuration of your repository, and then you are good to go. Once you make, for example, a pull request, or once you make a push, you define it, then the analysis will be executed, and the results will be presented within the pull request, or will be sent to Qodana Cloud, where you can also see them.
On that note, would you say findings in the Taint Analysis should break the build and therefore prevent deployments and stuff? If we're talking best practices, I have an idea what Grigory is going to say.
Interesting question. Actually, yes, we have true positives, we have false positives. So I think a rule of thumb is that any new findings that were detected by Qodana that should definitely block the pull request from merging. And then there are like different strategies. First of all, if that's a true positive, then you should definitely go on and fix the issue, and then it hopefully won't pop up. And if it's a false positive, you can add this problem into your baseline, and then new commit will trigger a rescan, and this issue won't pop up, and you'll be able to make a push. But yeah, so all in all, it is a warning sign, and it's up to you, how you deal with it. But if you're working on an application that is where vulnerabilities will be critical for you, then for sure you should handle them. But if you, for example, building your own pet project that you have no interest of sharing with other people, then you may not have to worry, but still you can use it as a learning opportunity to learn something new about software development or about vulnerability prevention techniques.
Gotcha.
Kind
Okay, I still have to ask Grigori, what's your opinion on this?
I think the answer depending on the maturity of the security policy or security team. If you have a good bandwidth, you can validate a lot of issues, have a lot of automatic tools. You can actually block the process and help developers to fix problems immediately. If you're not at the stage yet, you can start with like in a parallel. You have CI/CD that's running in a certain time frame, like every day or like every few hours, and have new issues, and you're validating them in the background and reporting back to developers. You're not blocking development team; they're still working their own pace. But if you find a vulnerable, like actual vulnerability exploitable, you can report to them, send it to proper channel, and raise an alert like, guys, we should block the releasing new version because you have this vulnerability. Yeah, but it's better to block it somewhere in a CI/CD. But if you're not ready, then it's better easier to start in parallel, detect issues. Maybe you'll find a lot of them, as you mentioned, like some of them will be true positive, some of them will be false negatives. Then you should kind of deal with your legacy. It's not a new application. Usually you have some depth in your code base.
I think this is a very pragmatic approach where you either say, okay, if we're a mature team, then sure, we should put things on hold and make sure security issues are addressed. But if you're still in like an early stage, then it's like, well, okay, let's keep the development team moving, but make sure we address those properly before actually going live. So I like this approach. Thank you. Dima, we touched very briefly on AI and we have 8 minutes left. Do you think you can share your AI vision for Taint Analysis and Qodana in 8 minutes, or do we need a separate session for that?
Well, we'll definitely need a separate session. But actually, I would say we have a secret motto in Qodana team. So we believe that in ideal world, in 2025, at least at the end of 2025, we want that every line produced by AI will be checked by Qodana, and every line of Java and Kotlin code will be checked by Taint Analysis as well. It's ideal world. And like if you are using JetBrains products, that will be the case. So if you are using Qodana, then you can integrate CI/CD and make sure that every AI technology that you are using will not produce malicious code, at least in those cases that we've programmed our analyzer for. And we'll try to at least help you to mitigate those problems that we find. However, so if people are not using Qodana, they still can make use of AI. So they can, for example, they can go to some web portal with AI. There are a lot of different platforms, right? I will not name any specific one. They can ask them to create some code for them. They can paste in our IDE, and our inspection, if it will be installed, will also check all this generated code. However, yes, as I've already told, not every user is using JetBrains ADI. Unfortunately, I hope this will be changed with help of our inspection as well. But even in those cases, I would definitely recommend users embedding Qodana in their CI/CD pipeline, so that can still make sure that the code generated by AI will still be checked against the rules that we are working on. Yeah, and because like everybody heard those stories, like there are people with lower technical or absent technical background that are doing vibe coding, and they are just making their dreams come true. And they create some products, some like really fascinating products. They make them live, and then like bad people who are trying to take those products down. So we are trying to help those people within Qodana, so that their code that they will generate with AI will be checked, and that they can see the issues, and then they can ask AI, for example, AI assistant, for help, so that it will help them to mitigate the issue the way that Grigory showed you already.
So we're running short on time, but I do have to ask this question, because on the one hand, we're talking about, like, or Grigory showed this like, oh yeah, let's just use AI to fix our security issues. And the way you are talking about it is more like, well, AI is going to introduce malicious code. So what's it going to be?
Both.
Well,
I think both.
Both.
Yeah, I could help you that solve security issues if you ask properly, provide a good prompt, and if you provide a prompt to generate code, it may generate insecure code with vulnerabilities. So two kind of
And
things.
our engine will prove that the solution that was provided by AI to fix the problem is correct, and runs one time more and check that everything is okay.
Yeah,
And
if
just
you
one
disappear,
warning
those
from
effects.
me. One little warning from me is just not to try to use like some unknown AI providers. Like there are like many LLMs available on the internet. You're not quite sure what was the data they were trained on, whether they can create some intentionally malicious code and stick to well-known providers. For example, you can use AI assistant, and we are trying to do our best in order to generate the best code possible within our products. And then you can also do some kind of double checking with the inspections that we deliver on top.
Gotcha. Out of curiosity, and I really don't know the answer, but can we provide findings from Qodana as context to AI Assistant already?
Not yet. However, we are working towards that direction, because there are like
Cool.
new products coming, and we already have the opinion that we cannot reuse our findings as is. However, we have planned such an effort with one of our products, so that we'll optimize the output of our inspection directly for the product needs, so that it will be able to work with it and to rewrite the code if it's needed.
Cool. That sounds interesting. I'm very excited to hear more about that eventually. Awesome. Having that said, I think we should wrap up things here. Thank you all very much for enlightening me and some of the viewers about Taint Analysis. And let's pull up my 2 more slides that I have. Just perfect. So in case the people out there want to learn more about this, I can highly recommend the Qodana blog and our website in general. This is also where we will inform you more about events like this. So if this was like, this was great, I learned so much today, then make sure to check out the next slide that I prepared. As a usual YouTube thing, please like and subscribe and blah, those kind of things. So in case we do things like this again, you'll be notified about it right away. Thank you so much for joining. And also to my lovely colleagues, thank you. Appreciate you.
Thank you.
Thank you.
Thank you very much.